something that I don't want to omit is the possibility of using constraints actually. So let me come back here. This is important just in case you want to use it, and actually I believe we want to use this for our final sand grains, vellum grain simulation. Let's go to the basic setup that I did in the beginning, and I'm going to remove all this, the group, just disable it, just keeping this. Right after the vellum constraint grain, the configure, you can append vellum constraint. Constraint. So what you're going to do is connect this is the actual constraint representation. You can, if you want to see it, you can connect a null, append a null in the one in the middle. Enable, you can see these are a guide that represents the constraint. Something that at the moment is showing nothing, no constraints at all. And that is because we need to switch these 2 points. Actually, let's change on the constraint type. Let's use glue, and this should be point. Now we can see we have the guides that the guides that are showing us the constraint. We can play with important values here, such as the constraint per points. You can see that it's already connecting a lot of points here. Let's make a test with this. But the idea, before that, in order for this to properly show us what's going on, let's animate quickly a sphere that is going to be a collision. Transform. Transform. Let's put the central expression in the pivot. And connect that in the second input. Usually I use collision source, use the volume proxy, but for this it won't be necessary. Let's just bring it here. And use the expression of input path. It's on the first, the index is 1. We can just copy paste that here. We can see if it's evaluating correctly. It is. Use a merge. And let's animate this quickly. So we can move this guy. And then we can animate it like here all the way to. This is just a quick animation just to see the result we have with the constraint. I think we want to disconnect the solver. We're not going to use it now. We want to make this deform. Yeah. Enable this. The reason this is not working is because we need to disable auto slip. Let's take a look. So now you can see we have very nice clumping. Even though we are disabling the custom attraction weight, but we kept attraction weight value of 1 inside the .NET. I just wanted to show you that this is really a good solution to generate clumps, wet sand, and we might use it in our setup. Let's jump to our setup, continue developing that. Something I want to do here, and I recommend it, because we're going to keep increasing the resolution, is to probably procedurally delete a lot of these guys here so we can make quick iterations. My idea to do this is using time shift. We can connect the car body here. I'm going to have two. One is going to be the first frame. It's 980. Actually, let me just duplicate this one. We're going to add something like, let's see, like 20. Let's see if this works. We're going to merge these two guys, and we're going to use a bound. So the bound, if we reference the sun, we can now change some values here to select the whole area. And we can even go further here. So this way we can just use a group. On the second input we connect the bound, and on the first one we connect our Vellum. We're going to use the keep bounding regions and use bounding object. We need to change these 2 points. So now we can blast all these points, use way less sand for our setup. We can now go even further on the resolution. Let's increase this from 0.025 to 1.1. We can. I think this is as far as I'm going to go in terms of resolution. It's going to be a really good one, and we're going to be able to render nice grains with this. We can even delete more of these guys just to make quick iterations. And to do that, I'm going to reference the car. I will just select a bunch of points here and delete. Sorry about this. I think I need to, for now, do this. Here, select this guy and reference the car. Now I can select points, grains, and just blast it. But we're gonna keep this part because this is a consistent number of points. It's not changing. You can also delete this way just for the purpose of a quick selection of points and get fast iteration. Now let's connect this here. And as I mentioned before, we're gonna play with the vellum, the constraint, the grain constraint, the glue. But there is a big gap here. We can adjust for now the starting point. Let's make it 1001, so we can have the car, the SUV, just getting closer to the grain for our test. Now let's go to this part, and we're gonna append the constraint. Let's tweak some of these values. Again, we need to change these 2 points. The distance, the constraint type, make it blue. And change the target group type to points as well. Inside my .NET, I'm going to change the value of this attribute transfers. I'm going to increase it to something like 0.007. Let's start playing with some values in the constraint, and then we can have quick iterations and see what is the best value for this. Oh, something that I also want to do, I might want to increase the substeps. But let's see what we get here. I'm going to change this to 20. And I'm going to enable breaking and leave this value there. Okay. I'm going to reduce the constraint iterations to something like 10. Inside here, I'm going to add pop drag. Change this to manual so we don't cook every time we make a change. I'm going to change this to 0.01, just a little bit of drag so we can have a little bit of control on the crazy, some of the grains might behave weird and just fly out like shooting with crazy velocity. In the Vellum solver, let me just check. I'm going to put this back to 2.5. And I'm going to increase this to something like this. And I'm going to make it. I'm going to increase also the chalk scaling to very, very high value, like 80. The reason I'm doing this is because every time we make our grain thinner, we increase the resolution, we will have a big, we will lose a big loss on the choking power, on the way is the massive choke, it will be less. So you need to compensate these values. See what else. I think we're ready to make a test. Let me make a quick test here and see what we get. Okay, this is my test. We can see very crazy thing going on here. This is happening because we might need to increase the sub-steps in the simulation. So I'm gonna I'm going to go and change that and make another test and see what happens. I'm going to close this. Well, I'm going to keep it open. I'm going to go inside here, and the sub-steps, I'm going to make 10 on this particular case. And let's make another test and see what happens. Okay, here's my test. This is starting to look super nice, super cool, except for some crazy velocity values, as I mentioned before. But we have nice clumps, accumulation, granularity. We have a good power on the choking, on the collision. So this, I'm very happy with this, except that we need to figure this out, find out what's causing this crazy velocity. So I'm gonna look for that. I'm gonna investigate this, and I will come back with a solution for you, keeping the values as we have it, but just solving, debugging the problem we are having here.